Everyone. I would like to today present with you my exploratory data analysis project on Amazon Prime dataset. So over here, I have a collab file where I've performed EDA operations on the dataset. So I've cleaned the dataset, I have pre-processed it, and then I've created very interactive visuals using Seaborn, Matplotlib, and Plotly to kind of summarize the data and the insights we have found from this particular project. Also, I have created a Streamlit app, which I've deployed on Streamlit community. So over here we have, let me take you through it. We have a sidebar where we can select any page. We have multiple page options. We have a page for univariate analysis, bivariate, multivariate, as well as we have a Power BI dashboard that I have also created. So it's a snapshot of the Power BI dashboard. Let's take a look over here first. Then we are going to revisit this Streamlit after we have checked the code. So over here, this is kind of a snapshot of the Power BI dashboard that I've created. So it looks something like this. We have slicers, change the data. We have some graphs, donut graph, line graphs, scatter plot, and bar plot. We have some KPIs that we can choose from, and the logo over here. Now, okay, so let us go back to the Streamlit. I'll show you more features over here. So over here we have a GitHub link. If anyone wants to visit this project, get an idea, or even make a clone for themselves, they can visit this page and check everything. I've also enabled a README file over here, which is very elaborate and gives some brief idea of about the project and also the steps through which you can run this particular project. So you can take a look here. So I've also provided downloadable links to download the resources. So over here, we have two kinds of resources, the titles dataset and the credits dataset. So if you will, let's say, click on the titles dataset over here, we'll go to your downloads and you'll say, see a button saying done, has been done. So it's an information button over here. It's a success button actually. Yeah. All right. So now we over here, we have a video. So this will kind of explain all my EDA project and give a visualization look of the Streamlit as app as well. Now over here we have some brief information about our Amazon Prime TV shows and movies, which we are going to also check in the EDA. So for now you can take a look. This is a list of the import modules that I've used for this particular project. So Streamlit I've used to create the Streamlit app. The pandas numpy is for data manipulation and to create data frames. The matplotlib, seaborn, and plotly, these are for the visualization tasks. Okay. So over here, we have a small code snippet on how you can upload the, or how you can actually read the CSV files and convert it into a data frame for further processing, cleaning, and visualization tasks. Over here, we have a first look on how our titles dataset will look. We can see we can scroll directly in the Streamlit, so it allows us to be very interactive with the project. Also, we have a short summary, which tells us the number of rows and columns we have over here. The same goes for the credits dataset. We have the data regarding credits. We can also do other items over here, selection like we can sort and everything. So it's part of Streamlit directly. It allows to be very, can interact with this Streamlit app, gives a very good summary, a high level summary of our project. Over here, it tells us how many records we have for the credits dataset. Now we have a side-by-side comparison for the variable description of the titles dataset and the credits dataset. This gives us a very unique kind of comparison because we can clearly see what kind of columns we have over here and what columns we have here. We can see this ID column is similar in both the tables. So when we later merge these tables, we can utilize this common column. Now here's some other brief description, which we will see in detail regarding the types of variables we have, some content composition, ratings, and other data. We are going to visit all the other graphs from here. Code we'll see through our EDA. So let's move on to this now. So let's first discuss a bit of the project summary. So Amazon Prime TV shows and movies. This particular EDA is based on doing in-depth analysis of Amazon Prime's content library. And our motive is to find some patterns, some insights and trends that can really impact the business and help in its growth. So we have two kinds of data set as we talked earlier. We have the titles data set and the page data set, and the different kinds of columns we have. So about 15 columns and 980, 9,871 rows for titles data set, and about 1,24,000 rows in page. In the EDA, I've also provided the GitHub link for this particular project. So if you click on it, this will take you to the EDA project. So this EDA project that we saw over here. So now let us move on to the main part. Let us first import our modules that we have used for the file. Let's run it. So over here we have used all the processing and visualization modules. Also, I've imported OS module, which will help us to do some, which will help us to create path for a data set. We can fetch the path from our folder using the OS module. So now next thing we'll do is we are going to mount our Google Drive, and over there we are going to upload our data set. Data set you can download from here, or it is also provided in the GitHub link. So you can download from there too. Now let us first mount this. So I've already mounted, but if you mount it now, this will take you to some steps, show you some steps that you can follow. And also we have uploaded the data sets over here. So you'll have to upload it. Okay. Then you can use it to the further processes. Now over here, we have specified the path for our data sets. So our data set is currently inside the content folder, and this is the name of our data sets. Now we are using the os.path.join function to create a final path for our data sets. And then what we are going to do is we are going to load this data set we'll convert this data set into a data frame. All right. Now let's take a first look how our data set looks. So we saw that in Streamlit. Let's take a look over here in detail. So let's do titles.head. All right. As you can see, we have a lot of columns over here. So this will later help us in visualizing to find the kind of relation two columns have on each other. So we can see we have a title, type, description, release year, age certification, runtime, genre, production countries, and so on and so forth. And DB ID, IMDb score. For the credits, we have about 5 columns, and you can see we have a character column and a role column as well. Also, we can see this ID column over here in credits is same as ID in the titles. So later on, when we are going to merge both of these data sets, we are going to merge this on the common column ID. So now let's get some brief idea about the data sets. So this just shows us how many rows and columns each data set have over here. If we want to visit the in-depth insight, like how many non-null values each column has and what is the data type of the column. So for that, we use the info, df.info function. Over here, now we can see the count of non-null values for each of the column. So we can see this seasons has a lot of null values. So the null count is very less. So we have to process all the null values in each of the column. So we are going to do a bit. Threads we can also see over here, the non-null values on the object. So first thing that we do before moving on to the pre-processing and the cleaning part is that we first remove the duplicates. Removing duplicates is very necessary because they can really manipulate insights, or they can divert a particular insight to a specific value. So Let's first see how many duplicate values we have. So we can see we have about 3 duplicate values in titles dataset, 6 in this dataset. Now we can also see exactly what the duplicated values are. Let's take a look. You can see these three are actually the rows which are duplicated. So we are going to remove it later. Otherwise, this is going to repeat in our analysis part. Similarly, for grids, we also have a lot of values which we are going to remove. Okay, now let us see the number of null values in each column. Here we can get an overall idea. How many null values do we have? What we have to remove? What processing we have to do? So we can see in age certification, we have a lot of null values. Similarly, for seasons, we have a lot of null values, which we have to later on process and do something about. Now we can also visualize the number of null values through a heat map. Let's take a look. Now we can see age certification has a lot of null values, and seasons I can predict has about more than 80% of the null values in this column. So this gives us a better idea which column we have to process, which column we can drop. So we can make some estimation that we can drop the seasons column, because it won't be really helpful for our insights part with so many missing. Okay. And over here as well in the grades, we have a lot of missing values in the character column. We are going to process it later. So this is some, what did you know about your data set? This is some basic idea that we just discussed about over here. And the type of variables we have, the categorical variables, numerical, and the text variables. Okay. Some other insight. And finally, when we complete our processing, we are going to get a very comprehensive foundation for EDA, because we'll have a structured and reliable data set that we can utilize upon. Right. Now let's see the columns in both of our tables. This over here, we are getting a list of the columns. And if we want to have some further description of each of the column in our data set, like the 25% quartile value, 50% range, 75% min or max, let's see for each of the column, we have the information, okay, numerical information. This really helps us to analyze the numerical columns, decide what kind of processing method we want to use. So now that we have seen the description of our data, next we are going to move on and see the number of unique values we have for each of the column. Let's take a look. So this will give us some kind of idea how many unique values we have. Then we can see we have 2 unique values in our type, about 11 unique values for the age certification. This will really help us later on when we try to visualize, so we can get an idea what kind of parameter we should use to split our data into different categories, and what other relationships we can make over here. And we can also see the actual unique values we have for each of the column. So we can see if there's any discrepancy in our data, like some particular data outlier which shouldn't be over here. Like for example, in age certification, we can see we have a null value, NaN value, which is a discrepancy in our actual data, and then we have to remove it further on. This way we can have a look at other data points as well. All right. So we can also see the unique values in the credits data set over here. Now let us begin to our actual data processing part. So firstly, the most important task is to remove the duplicate values, because duplicates can really divert our insights to a particular value. So if, let's say we have multiple duplicated values in our table. So during the processing, during the visualization and insights part, they are going to cause some issues. So it is always advisable to remove the duplicate values. So as we saw earlier, now I have dropped the duplicates using the drop duplicates strategy. And we can see if we still have any duplicate values, and we can see we have done. All right. Next thing we are going to see, we are going to find the percentage of null values in each of our columns. Beforehand, we saw the number of null values. Now we are going to find the percentage of null values. So, and we are going to use a metric, which is if we have more than 70% null value in any of the column, we are just going to drop that column. So this is one of the statistical methods. So if some column has about 30% null values, then we can process it for, let's say, 30 to 50. We can see what we have to do, either drop it or process it based on whether the column is important. But any column which has a lot of null values, in our case more than 70%, we are going to drop that column. So let us take a look. We can see the certification is about 65%, but it is an important column, so we are not going to drop it. But the season column has about 86% null values, so this is not going to be really helpful. What we are going to do is we are just going to drop this seasons. Now we see the remaining columns. We can see the season has been removed. This is some further cleaning that I've checked for the testing. So I'm checking after removing the seasons column, what all rows still have a lot of null values. We can see we have null values over here, empty values over here, and a lot of null values over here. So these particular rows are also not useful for our insights. So what we are going to do is we are going to fetch the index of these particular rows over here, and then we are going to drop these rows like that. All right. Now let us once see again. We'll see our null values have, we do not have any rows which have a lot of null values, so that is a good processing. Now we are going to do the cleaning part. For the category values, we are going to fill the null values with unknown. So we know that that particular data point has not been filled. Like for description, we are going to use the fill any function, which fills the null values, and we can see we do not have any more null value. For age certification, if we see the null values, we have about 6,000 plus null values in the beginning. And again, we are going to fill the null value with unknown. So it is going to remove the NaN data point that we saw where. Now we have zero null values. And we are going to find some ways to protect, process this unknown as well later. Similarly, for other columns, we are going to check the same. Now, our IMDb score column is actually a float-based column. It's not a categorical column, it's a numerical column. So for numerical column, our basis of cleaning or processing is going to be as such. So first what we are going to do is we are going to find the skewness. We are going to check whether our column is left skewed, normal skewed, or right skewed. So the statistical method is if a column has a skewness less than negative of 0.5, that means the column is left skewed. And if the skewness value has a value of positive 0.5 greater than positive 0.5, that means it is right skewed. Since a particular row IMDb score has a skewness of minus 0.3, which is between minus 0.5 and plus 0.5, that means this is normally skewed. Okay, so this particular column has a normal distribution, which we can also visualize using Hplot like this. All right. So now what we are going to do is we are going to fill the null values in this particular column by the mean of the category type. So what I have done is I have grouped by the category column. Category column has the type column has show and movie as different categories. So I've grouped by based on whether the data lies in the show category or the movies category. And I've fetched the mean of individual categories and then I've filled the null values according to it. So if we run this, and we are also rounding off to two decimal places. So now we can see we have zero null values and all the data points have been processed. Similarly, we are going to process this IMDb votes as well, again with mean, because we can see this is a visualization graph and the skewness is also in the appropriate range. So now after filling, we can see we have zero. And again, we have done further processing. So since we know the votes cannot have any points, votes cannot be in decimal. So I've just changed the data type of the whole column to int. All right. So similarly, let's check the skewness of the popularity column. We see this column is heavily right skewed. So the skewness is greater than 0.5. So over here, we are not going to use the mean for statistical methods. What we are going to do is we are going to use the median. So we can see this graph has a big right skewness over. What we are going to do is we are going to find the median value based on the type of the show, and then we are going to fill with that median value. Process it. Now we can see will be here. So this is the uh, values, top 10 values of the TMDB popularity. Right. So now similarly, we are going to clean other columns as well. Now we are also cleaning the credits data set. So any character which has a null value in the character column, we are filling it with unknown. And we can see the null values in the title has been removed. All the null values have been removed. And similarly for the credits, we have all the null values. So now next thing we are going to do is we are going to merge both of these data sets. So if we take a look at this data set, we can see we have a common ID column over here, right? In both these data sets. So what we are going to do is we are going to merge based on this ID column. So we are going to use a pandas function merge, and we are going to merge on left to left join and on the common column ID. All right. So if we take a look at the merge data set now, you can see we have all the columns from the character, all the columns from the credits, sorry, all the columns from the title. All right, so a further few processing on the merged data set, make it actually complete. Finally, we are going to fill all the remaining null values we have in the merged data set. All right, so now pre-processing is completed. Now what we are going to do is we are going to visualize if our data has some outliers. So outliers are those points which deviate a lot from our mean IQR, min and max range. So let us visualize it once. We are going to use the box plot to visualize. So we're here. We can see this is the range of our values. So this is the minimum 25% of the value, the median value 50%, and the 75% of values. And all these points are outliers. So outliers are those points which do not really help in finding insights. They are values which can be generated randomly or which won't really help us in finding the accurate insight or information that we're trying to fetch from our data. What we are going to do is we are going to remove this outliers based on the IQR method. So for each column, we are finding the 0.25 quartile range and the 0.75 quartile range to finally calculate the IQR. And this IQR we are multiplying with a factor of 1.5 or to find the lower bound and to find the upper bound. And then we format the data, clean it based on the lower and upper bounds we have found just now. So if we visualize it once again after clearing outliers, we can see we have a much clean data. We still have some outliers, that is okay. We, there are other statistical methods that we can deploy over here, like we can deploy variance, standard deviation. We can use some imputation methods and all. Clear this data. All right. So this is some information about the type of manipulation insights that we have done already. Now, so now that our processing part is completed, we can move on to the main important and the most interactive visualization part. So for the visualization part, we are again going to switch. We are again going to switch to our Streamlit. All right. Over there, I'm going to show you how all of these code depict the graph. And we are also going to talk about the insights that we found about. All right. So let's move on to our first univariate analysis. So univariate analysis is done when we want to find some insight based on a single column. So we have different kinds of univariate analysis graphs. Let us first check histogram. So this is how you can browse through each of the page in my Streamlit app. Select the column that you want to visualize, in our case IMDb score, and this is going to produce the graph for that particular column. So here you can see an interactive plotly based graph representing the distribution of IMDb score in form of bins and some insights that we have found from this particular graph. So this is interactive. We can see the data points, we can see the data count and IMDb score for each of our bin. We also have a distinction based on whether it belongs to movie or the show. Okay. And we also have another interactive slider, which we can use to change the number of bins that are being displayed. So here you can see our count of bins has increased. Similarly, we can manipulate it to show more or less number of bins. So we can, actually modify it. How many points do we want in a particular bin? What should be the bin width? And as such, we can find the density and we can modify the kernel density as well. Similarly, we can check multiple graphs together. If I just select two of them, so it's a multi-select box. I get a separate graph for the other column and a separate slider, which I can work upon. And similarly, I can do it for the list. So next we have box plot. So box plot gives us an idea of the distribution of data in the form of quartile range. So we check the distribution of IMDb votes based on which type of movie it is. Is it a movie or a show? You can see we have a box plot distribution over here. So similarly, we can find a lot of information by hovering our mouse over this. And even the individual data points, we can take a look. So what kind of data point it is, what kind of type it is, the IMDb votes it has, title and other description. Similarly, for the movies, we can see different data points. So this is interactive. And similarly, the insights we found from this graph. So we can check the distribution of our column, how our columns are distributed. So for the IMDb votes, we can see the most of the clusters are in the mid to high range. We have some extremely high or low scores appearing as outliers. We can see over here. We have some outliers, very further points from our main data, highlighting that some particular shows may or may not be more popular than others. So over here, we also have an interactive slider where we can select the year range that we want to display the visualization for. So let's say I change the year from 1961 to 2022. You can see the box plot is going to change. Go ahead, change this data. You'll see here. As you can see, our data points has changed based on the interactivity. So this is very intuitive, helps the user to understand our data. Right. Similarly, we can see the visualization for TMD clarity as well. Do not mind the noise over here. There's a little bit of. This is the graph for TMD popularity. Again, we have a slide to change the year. Next, we can also check the count plot, which will give us how many times a particular value is coming in a column, a particular category is coming. So we can see this drama has the highest number of value. So we can say that most of the movies and shows belong to this drama genre. Then we have the comedy genre. Again, we have a slider where we can choose how many top values we want to display. For now, we are displaying top 15 values. We can, let's say, increase it to top 20 values. You can see the top 20 over here. If we want to, let's say, top 5, then again slide it over here. You can see very clearly the top 5 most movies or shows which belong to a particular genre and the insights. We can see drama leads strongly in our genre category. Then we have other count plots. We can take a look. For the production country, we have this. So we can see most of the movies have been produced in US, then in India and other countries. You can also move the slider around, play with it, have a bit of visualization insights. Next, let's take a look at firstly the donut plot over here. So let us take a look at the age certification distribution form of a donut plot. So you can see we have a very beautiful donut plot made with Plotly, and we have the legends which show the various age certifications we have. We can see the R-rated certification has dominates the market. So most of the movies or shows are rated under R rated. Then we have PG-13. Some others is like a collection of many small age certifications which have been put together. And then we have some insights. You can take a look. You can see most titles fall under certain categories, TVMA, PG-13. So we can understand the audience demographics, what kind of shows or movies people like to watch in a particular certain. Then we can also check the genre. So this is a graph, descriptive graph of the genre. Again, we can see the drama leads as the highest concentration of values, followed by comedy, then documentation, and so on. All right. So this is the insights on this. You can see production countries, age certification, genre. Now let us move on to bivariate analysis. So in bivariate analysis, we use two columns and analyze a particular correlation on it. So whether they are related, are the values increasing, decreasing, or is there something we can find about? So firstly, let us take a look at the line plot. So in line plot, we are going to see the release year versus runtime. So over here, we can check the data points for each of the value. With with the increase of year, we can see the runtime for movies is increasing, and the runtime for shows is pretty much more or less the same. We have an average runtime of shows which is constant, but movies we can see is increasing, and we can see the temporal trends using the line chart, like how the metrics changes with the years, and then we can also compare with hue, which is a type, whether it's movie or a show. It helps us to kind of provide a story insights. So yeah, we can also see the distribution of release year and popularity. So this is pretty much more or less the same. We can see the popularity of shows has increased at some points, maybe due to the rise of OTT shows and all. And movies have been constant because there have been a lot of movies over the years. When in old times, movies were really light. Similarly, now for the bar plot, we can see the distribution between. Second, yeah. Now we can see the distribution bar plot for runtime with age certification. So we can see for each of the age certification, what is the average runtime. So we can see this PG rated certification has the most runtime, then followed by PG-13 and R rated. Again, have a lot of runtime. Similarly, we can see the IMDb score and age certification. So based on the age certification, what is the IMDb score? So TV-Y7 has the highest IMDb score, which is 8, followed by TV PG, and then we have some candidates in the 7 IMDb range. So this is really helpful. We can get some, good insight, like what particular shows people watch and which category of age certification does it belong. Whether it's a children's show, a show which can be watched by everyone, or A-rated, R-rated shows. Next, we have violent plot. So violent plot is similar to the box plot. Here we also get the distribution, kernel distribution. So we can see at what points we have the highest data concentration, then how it's changing over other values, and also information about individual points we have over here and here with the movie and the show. So here's some description, which you can also take a look at. Basic description over here. Now we have the bubble chart. So we have a bubble chart, which is kind of a scatter plot, a distribution between TMD popularity and IMDb score. And for the hue part, we are using the age certifications to color each bubble separately. So we can see this looks very pretty, and we can get some insights for each of the age certification. We can see the green, which is R, has a huge concentration around 6 IMDb score and around a higher TMD popularity. For the PG-13, we can see the IMDb score and popularity is changing a lot. So for a single IMDb score, we have varying popularities. That is some kind of outlier which we have to later on check detail. So this kind of information we can gather each of our age situation, which is really helpful. Now, last by-weight analysis is based on the tree map. The tree map allows us to watch or compare hierarchical data in the form of data density. So over here, we have chosen top 5 countries and top 3 age certifications which dominate that particular country. So we can see for the US dominates the market in number of total shows and movies. And even in US, the R-rated category, R-rated certification has the highest dominance, followed by PG-13 and PG. Then for other countries, we again find the same. For India, we can see we have the highest concentration in PG, then PG-13, and finally in R-rated. So yeah, this is really insightful from that we can, in a single look, find how these uh, data forms, these columns are related, which column dominates over the other. Here is some insights that hierarchical relationships we find the data. So this is a multi-category layers. We have one category, then we have the other categories. So this displays the proportion of each category within its parent. So we can quickly see the dominant types, genre, or countries. And so this is actually really effective when we want to see the category of data. So have instead of having multiple bar plots, clustered plots for different values, multiple categories, rather we are using a trim. It's the same. And we can also engage with it over here as we see. When you hover, we get the data. The total IMDb votes we have for this particular R category, the parent, what is the parent category. Over here, we can see the US. Finally, we move on to our last set of visualization analysis, that is multimedia. So let us see the heat map. So heat map is a type of visualization in which we find the correlation matrix of all the columns, all the numeric columns with each other. So what this does basically is this gives us a correlation index, correlation number between each of the columns, and we say that if two columns are positively correlated, like over here, IMDb score and TMDb score has a good positive correlation. That means if the value of one particular column increases, similarly, the value of other column will also increase. And if two columns have a negative correlation, that means they have an inverse relation. So if the value of one column will increase, the value of other column will decrease. So with our here color map, you can get a really good themed heat map, and we can see some insights that the columns we have over here, which we have used. We can see that positive correlations which move in the same direction and negative correlation which move in the direction. So this gives us a very professional look as well. It's really suitable for presentations, dashboards, and to make reports. And what are the insights from the IMDb score and IMDb votes? We can see that they have a mild positive correlation. IMDb score and IMDb votes, like IMDb votes and IMDb this has a correlation of 0.2. This is slightly positive correlation, not very heavy, but it is an okay range. Now, IMDb score and TMDb score, it has a strong positive correlation. That means both of them will increase or decrease. Some other insights that we have found. The general insight that most correlations are moderate. You can see most of the values are in the range of negative zero point 0.2 to positive zero point 0.2. So all of the values in a table, all the columns are mildly correlated. Now let us move on to our last graph analysis. That is a pair plot. So pair plot basically gives us a graphical representation of each numerical column with every other numerical column. So this is really helpful when we want to just have in one single look how the columns are visually related to each other. We can actually find a lot of insights by going through each of these scatter plots, pair plot formation, and we have a distribution based on the type. So in a single insight, we can find if two columns are related or not, and if they are related, then what kind of relationship do they have? You can see again some description. That dataset has multiple numerical columns, and a scatter matrix lets us to inspect the relationship between numerical variables. So we have this allows us to lottery allows us to have interactive exploration as well. We can hover the data right. We can also zoom in. We want to, let's say, a particular area. You can see check this way. You can see some particular area as well. So this is a lot of interaction that is provided. So yeah, that is all the uh, kinds of visualization that we had. Some overall insights regarding the scatter matrix that it allows us to explore the relationships, allows us to find outliers, and some type-based distribution observation. Now, lastly, let's take again one final look at our Power BI. This dashboard I've created on Power BI. So this is a final representation of my whole project. And this is the GitHub link for this particular Power BI dashboard. So if you want to go ahead and download this file and actually interact with this dashboard, you can download this code file over here and run it locally. As you can see, we have over here all the sliders and KPIs and all. So this is all for my project. Really enjoyed it. And you can also, this is deployed on community, Streamlit community. So everything is working. You can take a look, browse through. So thank you very much for this project. My name is Sadhu Sandhu, and this is my uh,